So taking up question number 13, if fx equals greatest integer x minus greatest integer of x by 4, where x is a real number, then question is talking about basically limit and continuity of this function. First one says x approaching to 4 plus fx exists, but 4 minus that limiting value does not exist. Second says it is continuous at x equals 4. Then again we are talking about left hand and right hand limit at x equals 4. So let's see this question. When you talk about the value of this function at x is equal to 4, you can clearly see f4 is coming as 4 minus 1, that is 3, correct? Now when you approach to this function for x equals 4 from the left hand side, you will have greatest integer of 4 minus h. So let's write down left hand limit, that is say f of 4 minus, correct? So this is greatest integer of 4 minus h, that will give you 3, minus greatest integer of 4 minus h upon 4, it's a fractional value, so its greatest integer is 0. So left hand limit is simply 3. Now go for the right hand limit. Right hand limit gives you greatest integer of 4 plus h. Let's write down f4 plus. So this is 4 minus, next term is greatest integer of 4 plus h upon 4, slightly greater than 1. When it is slightly greater than 1, so greatest integer will give you 1, finally turning up answer as 3. So we observe LHL equals RHL equals value is equal to 3, meaning that function is continuous at x is equal to 4. Let's move on to question number 14th. The common tangent to the circles x square plus y square equals 4 and one more circle given also passes through the point. Let's check this one. If you look at these two circles, you can clearly see the center of the first circle was 0, 0 and the radius was 2. For the second it is minus 3 comma minus 4 and the radius is 7. You can see it is 3 square, that is 9 plus 16 plus 24 giving you root 49, so the radius is 7. From these two we can see the distance between the centers is 5 units, the distance between these 2 points, and the difference of radii is also 5 units. Distance between the centers is equal to difference of radii, meaning that circles are touching each other internally. One circle and you have second circle. So the two circles are touching each other internally. Now you can draw the common tangent at the point of contact like this, right? Now let's see what the question is talking about. The common tangent to the circles also passes through the point. First you need the common tangent and then you need to check which of the 4 options is satisfying it. So let's go for it. Equation of common tangent is, how we can find? Simply s1 minus s2 equals 0. So s1 minus s2 equals 0 gives you 6x plus 8y minus 20 is equal to 0, or 3x plus 4y minus 10 is equal to 0. Now when you put the given points in this equation, 3x plus 4y minus 10 equals 0, you can clearly see option number 4 is giving you 18 minus 8 minus 10, that is satisfying the given equation. So the correct answer is option number 4. Let's move on to question number 15 now. The domain of definition of the function given by this one is simple question from domain. Let's check it. If you look at the first term, 1 upon 4 minus x square, your requirement is x should not be plus minus 2. For the logarithmic function, the requirement is x cube minus x must be greater than 0. That means x plus 1, x and x minus 1 is greater than 0. If you draw the number line, you can see here minus 1, 0, 1, plus minus plus minus. So these are the possible intervals. Combining the two results, meaning this one and this obtained result. What's the final domain of the function? Let's write down the domain. Therefore, domain of the function is -1 to 0 union 1 to 2 union 2 to infinity. I'm sure this is clear. Let's see from the given options. We can see option number 2 says -1 to 0 union 1 to 2 union 2 to infinity. So the correct answer is option number 2. Let's move on to question number 16 now.